This is the comprehensive SESC Plan Review and Design Refresher course, Module 2. In this module, we will be looking more in depth at the Plan Review and Design component of the refresher course. This will include identifying some of the more common issues and problems encountered during the Plan Review and Design portion of the permitting process. We're going to begin by examining the 13 minimum required elements of an SESC plan. The expectation is that all plans will have each of these elements. When EGLE performs a program review, we look for every item on every SESC plan we review, and often find errors or omissions. We're going to break them down and discuss why each element is important. The first three are obvious: a site location map, legal description, which identifies property boundaries and proof of ownership and can include the parcel number, and a site location sketch. This can be as simple as an image printed from Google Earth and should have a town, roads, or highways indicated so that basically at a glance it will tell you roughly where in the county or township the project is located, and it doesn't need to be to scale. The proximity of the project. The plan review designer may create this in a narrative format, or it may be indicated on a scaled map. Whether the nearest lake or stream is 100 feet away or a half-mile away, this is important information to have to determine the characteristics of the watershed and where runoff will flow. If earthwork is over an acre in size or is taking place within 500 feet of a lake or stream, an SESC permit is required. Predominant land features. What land features are currently there, and what will change? Examples of predominant land features are roads, trees, farms, houses, and water bodies. Slope information. This should include pre- and post-construction conditions. This tells us how much grade will change or how much cut and fill activities will be occurring at the site. It also identifies where flow patterns may change from sheet flow to concentrated flow. This may be indicated by contour lines, or the information can be included in a written format or using arrows. Now we're going to spend some time on soil information. The next several slides will discuss why it is important. The soil information can be written on the plan, photocopied from a page in a county soil survey, or provided with soil borings. Some SESC agencies require the soil information on the permit application. Is it clay, silt, or sand? And why is that important? In general, sand will allow high amounts of water to infiltrate and will settle out quickly. Sand also has low erodibility and low runoff. Silt soils are easily eroded or highly erosive. They have a moderate potential for runoff because it isn't easy for the water to soak through the smaller particles. Once suspended in water, silt particles may flow quite a distance as they aren't heavy enough to fall out. Clay soils are problematic for soil erosion and sedimentation control. They have a high runoff potential and low infiltration rates. It is difficult for the water to pass through these tiny particles. Clays have a moderate potential for erodibility. Once in suspension, the clay particles do not settle out and can be carried great distances. The implementation of SESC measures must be greatly contemplated on sites with clay soils. Clay soils are soil groups C and D. Silt soils are group B, and sand is group A. We'll discuss these groups in more detail. Soil texture refers to the proportion of sand, silt, and clay-sized particles that make up the mineral fraction of soil. Understanding the soil texture is an important part of SESC, allowing the plan designer to appropriately select the SESC measures for the area by indicating which areas are prone to erosion. Sand is bigger in particle size and heavier, so it drops out of suspension easier and faster. Silts have the consistency of flour and will stay in suspension longer. Clays stick to each other and our hands if we touch it and has the smallest particle size. Loam is a mixture of clay, silt, and sand. We referenced settlement rates earlier. As you can see on this slide, sand has a high infiltration rate and low runoff and is in hydrologic group A. Sand settles out quickly. Clays are in hydrologic groups C and D. They have a low infiltration rate and high runoff potential. USDA's Web Soil Survey is a great resource for information about the soils located on your site. Let's look at how to use the Web Soil Survey in this brief tutorial.
So an easy way to find out what kind of soils you have on your site is to use the USDA Soil Survey. It can be found on the web by simply going to a browser, typing in USDA Soil Survey, and searching. You want to make sure you're getting on the right site, so make sure it says websoilsurvey.nrcs.usda.gov, and that's the one you want. Once this page opens up, you really only have to hit Start WSS, and the best way I think to find your location is by typing in the address, if you have an address, and hitting enter. So the program takes us to our little address spot there. Next, you need to select your area of interest. You can do it by a rectangle or by drawing a polygon. I'm going simple with just a little rectangle. This is just telling me there's multiple soil surveys in my area of interest, which is okay with me. I want to go to my soil map so I can see what my soil types are. And there they are. So let's say we want to do some clearing and developing here along McClure Road. So along McClure, it looks like on both sides of the road we have BNF for our soil type. So I'm going to come over to the left-hand side of the screen here. Scroll down and find my BNF. It looks like we've got Boyer loamy sand there. It's got 25 to 50% slope. It's a pretty slopey site. We're either have to take that into consideration when we're designing, or if we've got the opportunity to maybe move somewhere else or look for an area of less slope, that would be nice. So we've got a little bit of a slope. Let's go ahead and click on Boyer loamy sand there. And look, it gives me a lot of other information. So let me see what else have we got here. Back slope, slide slope, riser. We've got, it says that our slope is 25 to 50%, right? We knew that. Drainage class is well drained, runoff class is medium. We've got hydrologic soil group A, which would say that it probably has pretty decent infiltration, right? Although the slope may be affecting that, as it's quite a slope. All right. So with that, we'll go ahead and we'll take a look at our Soil Data Explorer. And then we'll go over to Soil Reports there. We'll look over here on the left-hand side, we find soil erosion. So let's see, RUS2 related attributes, click on that. And then I'm going to say View Soil Report. Alright, when I scroll to the bottom here, I have my soil report. So I'm in my Washtenaw County. I'm in my BNF, Boyer loamy sand, 25 to 50% slope. It says I got a slope length of 98 feet. I'm in my hydrologic soil group of A. I can use my K factor for calculations, but instead I'm going to go to a website that does the calculations for me. So let me open up a new tab. Go ahead and type in Russell MSU, and there it is. Again, I want to make sure I'm going to the right website, so this is msu.edu. And this site will help you calculate your erosion rates. So we'll go down to calculate erosion. We've got a construction site, so I'm going to select that. We're in Washtenaw County. So there that is. Click next. Alright, you can put your site ID on here if you want to. I'm not going to fill that in, but I am going to say, okay, we've got We're just try and stick to our 25% slope. I don't really want to be building on the 50%. And our slope, our length of the slope was 98 feet, we said. Well, the closest I got is 100, so I'm going to select that. I've got my Boyer BNF right here. And let's say we're going to clear 2 acres. All right, and down below, we're just going to say, yeah, we're not going to put anything on it for now. We'll take our chances, right? How bad can it be? Hit continue. And it calculated our tolerable, or our calculated soil loss for us. So that's in acres, or tons per acre per year. Looks like we're at 78.03 tons per acre per year, which is unacceptable. So it's showing us in red, and then it's got the asterisk says, you know, the erosion from this site appears to be higher than the tolerable soil loss. Well, yeah, because the tolerable soil loss is 4 tons per acre per year. So we got to try and get below that. So let's go on back. We're going to have to add something to it here. So let's see. Straw. We've got a land slope of 25. But see, the run can only be 75. So that's not going to work for us. Nope, doesn't look like we can put straw down. Okay, the next one here is crust stone. Let's see. Yep, we can do 21 to 23 inch slopes, or percent slopes, and we can go up to 100 feet. So let's try that. Throw a little stone on there. And looky there. Our calculated soil loss is nicely, just barely, below the tolerated soil loss. So that would be acceptable. Let's try a different type of cover and see. Let's see what the wood chips do. We got a wood chips here, yeah. So there's 21 to 33% slope, 100-foot length. Try that. See what we get here. Wow. Yeah, now we're doing real good. So our tolerable soil loss is 4 tons per acre per year. Didn't change, right? But our calculated soil loss now is only 1.56 tons per acre per year. So for the potential soil loss total is still underneath the tolerable soil loss. So that's great. And hey, wood chips are probably cheaper too. Alright, so there's your tutorial on how to do the Russell equation and how to use the web soil survey. Hope you learned something out of it, and hope you get a chance to use these tools to help you with your soil erosion and sedimentation control.
Finally, during our discussion of soils, rainfall can affect erodibility and runoff. This slide displays inches of rain for a 24-hour rainfall event based on rainfall frequencies, location zones, and the probability of an event occurring each year. A county in Zone 6, for example, will have how many inches of rain in a 2-year event? The answer is 2.27 inches. EGLE recommends that SCSE measures are designed to withstand a 10-year rainfall event. Moving on to our next element required by Rule 1703, limits of earth change. This one is commonly omitted. The area of disturbance needs to be defined and will not be assumed. The plan reviewer should undoubtedly know what the limit is. It is important to clearly define where permitted activity will start and stop. This ensures that work is being conducted only in the approved and permitted area, and that neighboring properties or water bodies will be protected. Dewatering and drainage. Will there be dewatering on site? Where will the dewatering bag be placed? The SCSE plans should not be approved unless the answers are known to these questions. Water needs to be filtered so that leaving the site it is not sediment laden. The timing and sequencing can be demonstrated using start and end dates for less complicated projects, or a timeline that exhibits each phase or stage of the project for larger projects. Pay particular attention to project start and end dates. Starting to excavate in late November may be a questionable decision, as it is not practical to assume any vegetation would establish until late spring. Completing work in stages dramatically reduces the potential for erosion. The timing and sequence should include seeding windows. Seed planting windows vary greatly across the state. It is important to know the seeding window for your project area to give yourself the best opportunity to get vegetation established. This project was finished in the fall with seeding planned for the spring. What is going to happen during fall rain, winter melting runoff events, and early spring precipitation? Seed the ground early or use appropriate winter SESC measures. What temporary control measures will be beneficial to use on site? What are installation details and removal dates? Are the proposed measures and locations appropriate? For example, is silt fence placed in a concentrated flow area? Silt fence should be installed at the base of slopes adjacent to sensitive or critical areas and parallel to flow. Are there enough measures given the size of the project, complexity of the site, soil types, and proximity to critical or sensitive areas to sufficiently manage runoff? These are questions that need to be considered. This is an 8-acre site with steep cut slopes and no plans for seeding or blanketing until the end of the project. Several discharges were documented to the list. Should this plan have been approved in the first place? Both the SCSC agency and the permittee received violation notices. The plans were revised and the site was temporarily stabilized with seed and blankets. No further discharges from the site occurred. Permanent SCSC measures. The designer wants to consider the installation dates and methods. Does the location of the proposed permanent measures seem appropriate? Maintenance programs. A maintenance program for single-family home projects can be as simple as stating in writing that the homeowner will be responsible for maintaining vegetation on site. But what about sites with check dams? How will those be maintained? How about a sediment basin that is converted to a stormwater pond? Who will clean it? The developer, or is it turned over to the homeowner association? This is important information to know when creating an SCSC plan. Now that you are familiar with the 13 required elements of a SCSC plan, let's go over what is commonly missed and common mistakes. The first step in designing a good plan is conducting a thorough review of the existing site conditions. Are there steep slopes? Are there any critical or sensitive areas adjacent to the work site? If there is a water body, are there any wetlands or adjacent areas that should be avoided? Careful thought should be put into every SCSC plan. This will enable the project to move forward smoothly and remain in compliance. Anytime a construction project is immediately adjacent to sensitive areas like a stream or lake, plans should also address critical areas, such as steep slopes. Here is a portion of a schedule. It is clear, both in time and space, how this project will progress. Looking at these slides, what of importance do you notice? Is it clear when SCSC measures should be installed? Silt fence should be installed before earthwork starts and removed when the area is stable prior to submitting a notice of termination. This is from a large construction site in South Haven, Michigan during a light rain. You can see the sand particles settling out behind the straw barrier. The clay-sized particles are passing over the straw barrier through a small sediment basin, through a brush barrier, through 3 layers of silt fence, and discharging into the Black River. This site is in Van Buren County and had sandy clay soils. Look at the sand that settled out first in front of the straw bales. However, you will notice the clay continued to discharge despite several SCSC measures in place. There are a lot of SCSC measures in place at this site, but the soil type on site makes it difficult to control sediment from leaving the site during rain or snowmelt. This is the outlet to the Black River from the previous picture, and there is a discharge taking place. A detailed staging plan or the use of PAMs are tools that may have prevented sediment from discharging to the river. Remember that it is important to know the soil type, slope, and proximity to a water body. In areas of sheet flow, silt fence allows sediment to drop out and water slowly infiltrate through the woven geotextile fabric. The fence is not effective in concentrated flow areas. What may have been a good alternative here? Perhaps an appropriately sized and properly installed check dam. Jute is not a suitable substitute for silt fence. Sadly, these are photos taken on actual project sites. Clearly, the silt fence is not preventing sedimentation from occurring. This is a picture of deposition at the bottom of a hill. The erosion controls on site must not have been very good because a lot of sediment has deposited, enough that the silt fence was overwhelmed in several areas. The silt fence in the foreground looks good. What about the silt fence in the background? This technique for starting a course of silt fence is not recommended. There are many benefits to using temporary check dams. 2 of them are that they are reusable and safer for traffic. The top diagram shows the elevation from the toe of the upper dam to the top of the overflow of the downstream dam. The bottom diagram is for a manufactured check dam. The spacing and need to bring the dam all the way to the side of the slope are the same. This check dam is not properly constructed. It is decreasing the channel's ability to hold water and instead is acting like a series of step pools. At this check dam, the stone is too small. The sides of the channel are not covered with stone. It should be lower in the middle. The flow is coming towards us. It's difficult to see, but there's some side cutting. Look at the middle check dam. The sides were either not brought up enough or it was not centered. This series of dams have good spacing, but the stones should be carried up the side slopes more. The middle should be lower to allow water to cascade down the rock. Here, soil erosion has taken place. The sediment has been deposited before the check dam, before the dam slowed the water, which caused the soil to drop out. You never know what you will see when you are doing inspections. There is no one size fits all when it comes to inlet protection. The effectiveness varies depending on soil types and is not highly effective with fine silts and clays. Pre-manufactured devices are preferable. Placing rolled fabric under grates is never recommended. A few counties require the use of silt sacks instead of fabric drops. We don't prefer fabric drops either because of the maintenance issue. However, if the wrap were over the grate rather than underneath, you could at least remove the sediment without dropping it into the inlet. The inlet protection requires maintenance in this photo. It is important to not rely solely on inlet protection for your site. Phasing and staging can reduce erosion from occurring and therefore reduce sedimentation and the need for maintenance. Ensure that there is a plan in place to remove the inlet protection so that the material does not fall in when the grate is lifted. Fabrics have no capacity for water, and clay seals them off and may cause flooding. This is not the proper way to address a flooding issue. Poking a hole in the fabric, although tempting, will simply allow the sediment to discharge into the drain. Here's a diagram of a gravel inlet filter constructed in the middle of a yard. Hardware cloth is wrapped around gravel, keeping it in place and protecting the inlets. Have you seen this at a construction site or had to deal with a neighbor's complaint? Track out of sediment can trigger many complaints. A rock access or street sweeping are typically required to address this issue. Next, we're going to discuss turbidity curtains. Keep in mind that if you are using a turbidity curtain, you will likely need a Part 301-303 permit from Eagle. The turbidity curtain is designed to isolate the work area. Now we are going to discuss rolled erosion control products. Make sure the blanket type specified on plans matches its designated use. You need to check the rating for longevity, slope, and velocity. Is the material being used straw or coconut fiber, and is it biodegradable? Make sure the product specified is appropriate for the site condition. Here's an actual installation. They did a great job. Here they ran along the top and trenched that in, then rolled down the slope along the channel. Here we see turf reinforcement mat and temporary check dams. This is a permanent control measure for vegetative growth. Once grass is established, it is comparable to 36 inches of riprap. This example of a blanket failure demonstrates how important it is to choose the right product and install it properly. The amount of money spent to remove the existing blanket, fill in the eroded area, reseed, and re-blanket with new product is quite costly. In areas where blankets won't work, consider bonded fiber matrix. This is a blend of mulch tackifier and sometimes fertilizer. It's rated the same as blanket and no anchoring is required. It is applied the same as hydroseeding. It may work better in areas not feasible for blankets or steep slopes. As we mentioned earlier, dewatering needs to be addressed with appropriate best management practices. Do not let sediment-laden water leave your site during dewatering activities. Plan, review, and design final thoughts. Plan the development to fit the natural site topography, vegetation, waterways, and soils. Stage the project. Expose the least amount of soil for the least amount of time. Focus on preventing erosion whenever possible. Do not rely on one measure to protect the entire site. Finally, operate a thorough inspection and maintenance program. This ends Module 2.